Hello, I'm Riaz, an engineer on the App Store server team. In this session, we are diving deep into the App Store server APIs for in-app purchase. I'll show you how our latest updates are designed to streamline and enhance your app server responsibilities. Let's start by exploring some of the key responsibilities performed by your app server. In this session, I'll focus on three critical responsibilities. First, manage in-app purchases. This task involves associating transaction data with your customer accounts so your app can deliver content and services seamlessly. Next, sign requests. This requires generating a signature to authorize your server's request to the App Store. Finally, participate in the refund decision process. By sharing consumption data related to purchases, your server can help the App Store make informed refund decisions. These are some of the many crucial responsibilities managed by your app server. Next, I'll explore how the new updates to the App Store Server API will enhance these responsibilities. There's a lot to cover, so let's jump right in. First up, I'll introduce updates to transaction identifiers that will help you better manage in-app purchases. Then, I'll look at improvements for generating signatures to simplify signing requests on your server. And finally, I'll review enhancements that simplify your participation in refund processes. Let's dive into the details, beginning with Manage in-app purchases. Managing in-app purchases starts with effectively handling customer accounts on your system. Typically, you would assign a unique account ID on your system, each customer, establishing a clear link between their account and the App Store transactions. This association is crucial for delivering the right content or personalizing the user experience. The App Store provides in-app purchase data through three key data structures: app transaction, GWS transaction, and GWS renewal info. First, I'll focus on the GWS transaction. I'll return to the other types later. When a customer makes an in-app purchase, the App Store provides a signed transaction object. On the server, the GWS transaction represents the signed transaction, which you can effectively verify and decode using the App Store server library. Here's a sample decoded signed transaction info. The first few fields contains important information related to the app and the in-app product type. Following that is metadata about the purchase, including quantity, price, and currency. If a customer redeems an offer, the GWS transaction includes fields for the offer type, offer identifier, and offer discount type. We recently added a new field, offer period, which indicates the duration of the redeemed offer using the ISO 8601 duration format. This field is also included in GWS renewal info, informing you of the offer's duration that applies at the time of next subscription renewal. Then there are transaction identifiers. The transaction ID is a unique identifier for a transaction, such as an in-app purchase, restore, or subscription renewal. In this example, it represents a transaction ID of the subscription renewal. The original transaction ID is the transaction ID of the original purchase. It helps you accurately identify auto-renewable subscriptions, as it remains consistent across subscription renewals. Lastly, the app account token, which is a UUID you set in your app using StoreKit when a customer makes an in-app purchase. This field enables you to associate the purchase with the customer's account on your system. To make it easier to get app account token for subscription renewals, we have included this field in the GWS renewal info. This will help you seamlessly associate your customer accounts with their most recent subscription renewal transactions. I'll explain how that works next. You start by generating a UUID on your server and associate this value with your customer account. Then, your server passes this value to your app built with StoreKit to set the app account token at the time of in-app purchase. We recommend using the same app account token value for all in-app purchases made by a given customer account. The App Store server returns the same app account token value in the GWS transaction and renewal info. Previously, you could set app account token during purchases that were made in-app. But customers can also make purchases outside of your app, such as when they redeem offer codes or make promoted purchases in the App Store. To provide you more flexibility to set app account token in such cases, we have a new server endpoint. Use the set app account token endpoint to set a new app account token or update an existing app account token for a transaction. You can use this endpoint for all product types. This includes past one-time purchases, such as consumables, non-consumables, and non-renewing subscriptions, and the latest purchase for each auto-renewable subscription. For auto-renewable subscriptions, the app account token you set using this endpoint carries over to future renewals, including upgrades or downgrades. The set app account token endpoint is useful when a customer completes a transaction outside of your app, such as redeeming an offer code. Previously, there was no way to set the app account token field for these types of purchases since StoreKit wasn't involved. Additionally, you can fix inconsistencies in associating app account token with customer accounts, such as when account ownership changes in your system. Now, I'll show you the endpoint, which is a part of the App Store Server API. Here's an example of using the set app account token endpoint. Provide the original transaction ID in the path. This value identifies either the one-time purchase transaction or the subscription that you want to set the app account token for. In the request body, set a desired UUID value for the app account token. The app account token you provide with the set app account token endpoint overrides any previous app account token set for that transaction. The app account token, along with other transaction identifiers such as transaction ID and original transaction ID, provide a way to associate customer accounts with the App Store transactions. Here's a brief overview of these identifiers. The App Store is the source of transaction ID and original transaction ID, while you are responsible for generating and associating the app account token with an App Store transaction. The transaction ID is useful to identify a specific purchase event. The original transaction ID is great for managing subscription lifecycle of auto-renewable subscriptions in a single subscription group, and for checking the subscription status. The app account token is useful to associate a customer's account information with their in-app purchase. If your app supports family sharing, know that app account token is not available for family shared transactions. Both transaction ID and original transaction ID are present in JWS transaction and JWS renewal info. The app account token is only available if you set it for a purchase either using StoreKit or the new set app account token endpoint. When a customer downloads your app, the app transaction object becomes available through StoreKit and represents important app download information. As transaction ID, original transaction ID, and app account token are specific to an in-app purchase, they are not included in the app transaction object. But sometimes it's important to uniquely identify an app download, such as for unlocking content at app install. So we have added a new field called app transaction ID to the app transaction object to help you with this use case. The app transaction ID is a globally unique identifier for each Apple account per app. For family sharing, each family member gets a unique app transaction ID. By design, the app transaction ID is static for a given Apple account and app across re-downloads, refunds, repurchases, or storefront changes. The app transaction ID is also included with any in-app purchases made by the customer within your app. This provides you greater flexibility in associating your customer accounts to all App Store transactions. I'll explain how that works next. Here's one way to use the app transaction ID to associate your customer accounts with the App Store transactions. First, when a customer downloads your app, associate the customer account in your system with the app transaction ID present in the app transaction object. One way to get app transaction object on your server is by sending this info from your app. When a customer makes an in-app purchase, JWS transaction and JWS renewal info include the same app transaction ID. So you can associate once and reuse across all App Store transaction objects. Since the app transaction ID is present across all App Store transaction objects, it unlocks some valuable use cases for your app, such as identifying whether two different subscription purchases belong to the same customer account. For example, assume that your app supports two subscription products, a monthly Bill Sports newsletter and an annual seasonal subscription to watch live games. How can you determine if a customer account has access to both subscriptions? Even though each subscription has distinct transaction ID and original transaction ID, they share the same app transaction ID. You can leverage this field to enable in-app customizations at launch, such as restoring in-app purchases. Additionally, you can use app transaction ID as the transaction ID for popular App Store Server API endpoints, like Get Transaction History, Get All Subscription Statuses, and more. Today, I'm pleased to share a new endpoint to get app transaction object using a server endpoint. With the new Get App Transaction Info endpoint, for the first time, you can fetch app download information directly on your server without relying on the device. You can use the app transaction object to check important app download information such as app version, platform, and environment. With this, you can understand how your app is performing with business model changes. Keep in mind, this endpoint does not return device-related details such as device verification. For those purposes, continue to rely on the app transaction object obtained from your app. Next, I'll show you the endpoint, which is a part of the App Store Server API. Here's an example of using the Get App Transaction Info endpoint. You can provide any transaction identifier, such as original transaction ID, or app transaction ID in the path. The response contains JWS-signed app transaction info. You can use the App Store Server library as one way to decode the signed app transaction info. The Get App Transaction Info endpoint will be available later this year. Now, I'll compare app transaction ID with other transaction identifiers that I showed earlier. The App Store generates app transaction ID as it does the transaction ID and original transaction ID. You can use the app transaction ID to uniquely identify app downloads and associate the customer's subsequent purchases with that download. The app transaction ID is consistent across all App Store transaction objects. You can use app transaction ID for family shared transactions if your app supports family sharing. We recommend using app transaction ID as it provides a one-stop identifier solution for all your needs. It simplifies managing in-app purchases and associating them with the customer accounts on your server. Now, let's jump into some key improvements we have made to sign requests. The first step is creating a JWS string, short for JSON Web Signature, on your server. You then sign this information using a private key that you download from App Store Connect. You then send this signature string to your app built with StoreKit to call functions that require a signature. StoreKit then sends the signed signature string to the App Store server. Previously, depending on your use case, you signed signatures with different formats as required by the App Store server. Now, we have unified signing requests across all use cases to use the JWS signature format. This means you can now use this format in StoreKit calls that require them, including functions such as generating promotional offer signatures. You can now sign promotional offers using the JWS signature format. This new signing method is an alternative to the previous promotional offer signature. To provide you more flexibility with introductory offers, we recently introduced a new JWS introductory offer signature. This feature enables you to set custom eligibility for introductory offers per transaction and per user, thereby having more control over the number of introductory offers a customer redeems with the App Store. You can also send signed JWS in-app requests with the Advanced Commerce API. For more information, please visit our developer documentation. I'll now show you how to create the JWS promotional offer signature on your server. Use promotional offer signature with StoreKit to retain existing or churn subscribers on your app. Here's an example of creating a promotional offer signature using the App Store Server library. I'm using Java for this example. First, I instantiate the class promotional offer v2 signature creator with a private key, key ID, issuer ID, and bundle ID for my app. You can find key, key ID, and issuer ID on App Store Connect. These values are used to sign the signature, which prevents customers from redeeming promotional offers without developer consent. Next, I specify transaction ID. Here, you can supply any transaction identifier that belongs to the customer, including the app transaction ID. Provide transaction ID if you want to limit the offer to a specific customer. If not, you can skip this field. Then I provide a product ID and offer ID. I have pre-configured the offer represented by this ID in App Store Connect. Finally, I pass the product ID, offer ID, and transaction ID to the create signature function. Notice that the new signature is simpler than the older version as it has fewer inputs. You can simplify signing requests across multiple use cases by using the unified JWS signature signing format. Even after providing an offer, it is sometimes possible that customers may drop off and request a refund due to things that are beyond your control, such as a billing issue or an accidental purchase. For such cases, let me now show you how to participate in the refund decision process. First, I'll share some benefits. You should consider participating in refund decisions because you know your customer's product consumption. For instance, when supporting consumable products on your app, you're already managing customers' consumable balances on your server. This can help improve customer satisfaction post-refund request. When a customer requests a refund, the App Store sends a consumption request notification to your server. To help inform the refund decisioning process, you can respond to this notification using the Send Consumption Information endpoint. I'm delighted to share a new and improved Send Consumption Information v2 endpoint. At its core, the endpoint is simpler to integrate as we have significantly reduced the number of inputs you provide compared to the previous version. The new endpoint also supports prorated refund preference to better represent partial consumption of a product when applicable. While the previous version of this endpoint only supported consumables and auto-renewable subscriptions, we have now extended the support to all product types, including non-consumables and non-renewing subscriptions. If you have already been using the V1 endpoint, know that this is not deprecated, but will continue to accept requests. If you haven't used the Send Consumption Information endpoint, we recommend using the latest V2 endpoint with the App Store server library. I'll now show you how to use the Send Consumption Information v2 endpoint. Assume that a customer has requested a refund for a consumable purchase and a consumption request notification was sent to your server. Here's an example on how to respond to the notification with the Send Consumption Information v2 endpoint. You provide the transaction ID in the path that you find in Consumption Request Notification. The new endpoint supports a total of 5 input fields, down from 12 in the previous version. Out of the 5 input fields, there are 3 mandatory fields and 2 optional fields. We have significantly reduced the fields to simplify your participation in refund decisions. Set the customer consented field to true if the customer has provided a consent to send the App Store the consumption data related to the refund request, including all the data you provide in the consumption request v2 body. If the customer has not consented, do not respond to consumption request notification. If the endpoint is called with the field set to false, the request is rejected. Use sample content provided to specify whether you provided a sample content before the customer purchased the product. Use delivered as a delivery status if you successfully deliver the content to the customer. Otherwise, use an appropriate undelivered status. You can optionally provide your preference for the refund. You can now consider providing a prorated refund preference using the grant prorated value, in addition to the already supported full or no refund. If you don't want to provide a preference, do not set this field. The consumption percentage tells the consumption of the product in millipercent. Here, a value of 25,000 represents 25% consumption of the consumable product. The Send Consumption Information v2 endpoint will be available later this year. Now let's dive into the new prorated refund option provided by the latest v2 endpoint. Consider providing a prorated refund preference in cases where the customer can partially consume the product. Prorated refund preference allows you to specify the consumption, helping the App Store grant an appropriate refund amount. It is required that you specify consumption percentage when you provide a prorated refund preference for consumable, non-consumable, and non-renewing subscription product types. This is so that App Store can accurately grant the appropriate refund. Note that the App Store calculates the consumption percentage of auto-renewable subscriptions for you, using the remaining time left on the customer subscription. The consumption data you submit helps the App Store decide to grant a full refund, prorate the refund, or decline it altogether. You're notified about the decision using a refund or refund decline notification. If you receive a refund decline notification, no action is needed. However, you're responsible to take an appropriate action when you receive a refund notification. Here's a sample refund notification. You can now understand how much of a refund was granted by the App Store using the new refund percentage field. In this case, a 75% refund was granted, so you can take the appropriate action for the consumed product. When using this field, remember that App Store Connect is your source of truth for all financial and accounting purposes. You can also understand the type of revocation using the new revocation type field. This field could be refund full, refund prorated, or family revoke. Since this is a consumable refund, the possible values are refund full and refund prorated. In case of a full refund or family revoke, you immediately revoke access to content on your server. For refund prorated, revoke the refunded percentage of the content. I'll now show you how to handle a refund notification with prorated refund on your server. In case of a consumable, non-consumable, or non-renewing subscription product, you use the refund percentage field to calculate and revoke the proportional amount of content from the customer's account. For example, if a customer purchased a virtual currency, you may wish to reduce their balance by the refunded amount. For auto-renewable subscriptions, handle prorated refund the same way you handle full refunds. Check the current subscription status and take appropriate action. I hope you'll use the new Send Consumption Information V2 endpoint to participate in the refund decision process, as it is now easier and more powerful than ever. We have covered a lot today. Let's quickly recap. I showed you various transaction identifiers and introduced App Transaction ID as a one-stop transaction identifier. Then, I explored the unified JWS signature signing format. Finally, I showed you how easy it is to participate in refund decisions. Before I let you go, let me talk about some useful next steps. If you have already made contributions to the open source App Store server library, thank you. Otherwise, please visit our GitHub page to learn how to contribute and support the App Store community. As we bring in new features, we'd love to hear from you. Please submit feature requests and feedback for the App Store server team with Feedback Assistant. To learn more about the updates we have made to StoreKit, visit WWDC25 session What's New in StoreKit and In-App Purchase. Also check out WWDC24 session Explore App Store Server APIs for In-App Purchase to learn more about App Store Server. Thanks for joining me today. I'll see you next time.